Hi, I'm Dave from Vivax Metrotech. I'm going to give you a quick tutorial on the vLoc 3 system. Let's start with the transmitter. It's a good place to start. We're going to make a direct connection locate for the power utility feeding this home. We've clipped on the meter base here, put our ground stake off at right angles where we think the direction of the line's traveling. Let's have a look at the transmitter itself. We're broadcasting at 32.8 or 33 kilohertz. We have 25 milliamps of current. Had a little bit of trouble getting the output until I scraped the connection on the meter base until it clipped up and gave me good signal. This is the on-off button for the transmitter. This is your increase the output, decrease the output. This F button changes the frequencies. Pushing the F button changes frequencies. And you'll scroll through whatever frequencies have been activated and made available for your use. So let's begin our locate. We've made our signal. We've got a good locate signal. Let's begin the locate. Typically, it's a good idea to step 20 or 25 feet away from the connection point to begin your search to see what you pick up. I'll step out here in the vicinity of where I think this line actually travels. On over, let's have a look at the receiver itself. If I push the on-off button, it'll light up. We're receiving in 32.8 kilohertz or 33, same as the transmitter. Our signal, we're in peak and null mode. Our signal shows 10 milliamps or 10.5 milliamps at about 4.5 feet. So my peak response is this one here, and it's showing red, which means the signal's nearby, but there might be a bit of distortion on it. And the null response is saying move in that direction. Compass is also telling me that whatever I'm tracing is going generally in this area. So if I move this way until my peak response, the red bar in this case, touches that blue bar right there, that puts me directly on top of the conductor itself. If I rotate the receiver now till the compass turns blue like that, that means I'm on top of and in line with the conductor beneath me. The null arrow tells me to walk a little bit to my right, so I'll do that. And the null arrow reverses itself right here. So here's my null response right here. Nice and crisp. And if I put my foot down there and move I can see my peak is just slightly to this side and the null is just over here a little bit, which means we have a little bit of distortion. And the fact that my bar up here is red is reminding me that there is a bit of distortion going on here. Usually if the null is pushed to the right and you feel some distortion, it's a good idea to go and check on the left. We'll go and check over there in a few minutes. Let's continue our locate and see what happens. So all we're doing is walking and listening to the signal. We've got a red display. We can actually hear the signal. We can hear where it's strongest. If I step over to about here and continue to follow this line, something kind of interesting happens. My peak and null are here. My display changed from red to blue, which means now I'm in a much cleaner field. Back there's a bit of distortion. Let's line this up. My compass lines up properly. My peak tells me the line is right here. And my null tells me it's also right here. That means we found our line. It's a good clean field. We're going to get good depth measurement and good current measurement as well. Let's put the receiver on the floor and see what we get for depth. It says we're about 3'7" beneath us there and about 11.5 milliamps of current. If I raise the receiver up about a foot, it should say about 4'7", and it says 4'6". So we're getting a 4'5". So we're getting a good depth measurement, and the current measurement's good and strong. And plus, we're seeing a little bit of distortion as we raise that thing up a little bit. So it's a good locate field. But a minute ago, I saw some signal from over on the left. Let's go and compare this field to that field. So we'll take the receiver. My gain is set at about 73 dB of gain. I step over into this area. Let's see what I pick up. I see a little bit of signal picked up right here. Just a little bit on screen, but I can't hear it because I have less than 20% signal. If I rotate my receiver, I can see I'm in line with whatever this thing is beneath me. If I turn my gain up a little bit like this, now I can hear, here's the strongest signal right here. Again, the display of the peak bar is in red, so that's telling us there's a conductor beneath us, but it's fairly distorted. That's also borne out by the fact that the null arrow is pointing us a long way in that direction. Let's follow the null arrow over. And the null arrow tells me this line is located, well, there really isn't a null response. It just kept pushing me over that way. So if I go back to peak and move back in this direction, I can clearly see where this line is. I can clearly see my display is in red, which tells me that there's a conductor down here. In fact, we can follow it if we just walk and follow that a little bit. So we can clearly see there's a conductor down here, and it's going in that direction, but there's no peak and null response. If I look at my current measurement up here, over there I have 12, here I've only got less than 4. So obviously, this is a conductor, but not our conductor. It says the depth is, let's have a look. It says it's 8 foot 3 inches deep, but in a distorted field, we know we may not get an accurate depth measurement. Let's raise it up a foot and see what happens. We go from 8 foot 4 to 9 foot 6. It's still a reasonably accurate depth measurement, but clearly this is not our line. This is some other conductor. This is oftentimes referred to as spilling or ghosting. I put signal on one utility and ends up on 2 or 3 utilities. In this case, the gas line, as compared to the power utility, we're connected up over there. So lots of good indicators, distortion indicators with the display, the color of the display, but my compass is nicely lining up in front of me. Let's go back over to our power utility and continue following that. Now we turned our gain up over there to pick up this weaker field. When I come back to my target line, I've turned my gain back down again. Just hit the button once. It'll automatically adjust itself down to give you a mid-scale reading. And then from here, we just keep walking. So now we can actually locate just listening for the signal. Anytime I want, I can stop and have a look down and see what's down there. Let's have a look at it. Here's my strongest signal, my peak response right here, right there, peak, and null is right beneath it. So our peak and null are very close together. Conductors here, again, we're back to 12 milliamps of current, 3 foot 9, raise it a foot. Now it says 4 foot 9. So we have a good depth measurement, good locate. Let's continue following this line down the way. We're using 33 kilohertz, by the way. It's a good general purpose frequency for locating power. I encourage guys to locate using their ears rather than staring at the display the whole time. All you have to do is adjust the gain until all you hear is this as you pass over the conductor. So it's not necessary to watch the receiver the entire time of the locate. It looks like this idiot planted a tree right on top of the power cable. So we just continue following. Now have a look at the display here. Back there we went from a red peak bar to a blue peak bar. Now the peak bar is green, which tells us this is a really good clean field. Here's my arrow telling me my compass telling me the direction of the conductor. My peak response is here. My null arrow says walk that way a little bit, and I do, it reverses. So we've got signal. We got a null response here. There's my null, and my peak response is actually right over where it says it is. So here it is in peak. Here's the null response right on top of each other. Nice clean field, green peak bar. So we know this is a good, I've got 14 milliamps of current, 4 feet deep. Raise the receiver up about a foot, and it goes from 4 foot to 5 foot 2. So we have good depth measurements, good current measurement. We're on the line we want to be on. Let's continue following this down. Now, as I walk from here, I can hear the signal as a certain strength. As I walk towards the transformer, where it's fed from, I hear my signal getting louder. Typically what that means is the conductor's coming shallower. Let's have a look at that. So we go back to our response. My peak response has now changed from green to blue, which means we got a bit of distortion here. Let's have a look at our strongest signal right there. Here's something else you need to know. Anytime you're locating, your signal goes right off scale like that, the peak response 99.9, stop wherever you are, hit the down gain button once like this, and the current will drop itself off to give you a mid-scale reading. In this case, as I come back and locate the line, here's my strongest signal. My peak and null are still agreeing with each other. I have 12 milliamps of current. I had about 13 back there, so it's good signal. My line's gone from 4 feet deep to 3 feet deep. That's why the sound got louder as we went. And as I raised the receiver up from 3 feet, now I got 4 foot 1. So we have good depth measurement, good current, but there's a bit of distortion here, just a bit. So that's likely caused by the fact that the way we attached our transmitter, we clipped on the housing itself, which means that we're now putting signal out on the service and potentially on other services nearby, or even the primary cable feeding the transformer. Let's have a look at that while we're standing close by. Our conductor is traveling in this direction towards the transformer, but I know the primary feeds across the front of me. So let's take the receiver and go over and have a look for that. As I pass over top of the primary trench, there's a little bit of signal on screen. It just showed up. I didn't hear it because the gain's not turned up high enough. if I adjust my gain upwards a little bit, there's my signal. And here's my signal from my transmitter right here. Again, we put signal on the service. It came down on the service, but now it's made it on the neutral of the primary. It's feeding the transformer. And so I've got a good signal right here as well. But if you have a look at the display, you'll see a couple of interesting things. First, the color has gone from blue over there to red over here. My peak response is clearly right here. I'll put my foot there. My null response is clearly way over here. So the reason that peak and null aren't together is because this field's badly distorted, which we were told by this display as well. It says I have 4.5 feet of depth. If I raise it about a foot, let's see what it says for depth. And it went to 4'11". Another good clue. This isn't my target line. The field's distorted. My current measurement's also it's less than 3 milliamps, where we had 11 or 12 over there. So clearly, the signal from our transmitter is making its way to the transformer and then lighting up the primary. And we'd pick the same signal up going the other direction as well, and likely the feed going across the street. So here's a situation where we make a signal, we find a signal here, we also find a signal there, but by comparing what the fields look like, peak, null, depth, and current, we can confirm that that's the line we want to trace, not this one. So let's go back over to our target line. Of course, we turned our gain up back there to find that weaker signal. So now we've got to turn our gain back down again to continue tracing this line. And we can just simply trace this right into the transformer. There she goes. So that's doing a power locate using a direct connection using a clip. Let's go back and do it again using the clamp and see what difference that makes. All right, we're back at our transmitter. We're going to disconnect the leads now and put the clamp on, see what difference that has in our locate. I'll turn my receiver off for just a moment. Disconnect the lead set. Plug the clamp in. Clamp around the stack itself, the incoming stack, which will be this one. We're still going to use 33 kilohertz. It's a good frequency for locating power utilities. So have a look at the transmitter here. It tells us that our batteries are full. We're in clamp mode. Our speakers turned on just a little bit. We're at 83 kilohertz now. I'm going to switch back to 33K by pushing the frequency button. There it is. And we have 1 bar of output, which means we're putting out minimal output. If I hit the up button like this, I can put out more current. How much current's actually leaving the clamp and traveling down the line, we won't know until we actually begin the locate. I'm going to turn it back down to level 1 because it's probably all we need. It's a fairly short service. So we're still in 33K. We come back to where we previously located this line, turn the receiver on. And a minute ago, we had 12 or 13 milliamps of current. Let's see what we have now. So here's my target line right here, same place as it was before. My peak and null are still nice and clean and very appropriate. My current's dropped from 13 milliamps to 9 milliamps or 9.5 milliamps. Still getting a fairly shallow depth measurement here. There's the peak, there's the null. So this is still a good locate. Again, it's cleaner here. The last time we did this, that bar was red, which meant we had more interference. Maybe caused by the fact that using a clamp, we put less current on the conductor, which will definitely put less current on that gas service over there. Just to check that out, let's go and have a look at that gas service that we located previously a minute ago. Let's go back over here, where a minute ago we were able to pick up this line because we made a direct connection, and now we're not picking up anything at all. I'll turn my gain up just a little bit to see if I can find some signal. And I'm really not picking up anything at all here that locks up. So the difference between using a set of leads or clip and a clamp means I have less current going out of my line and I have less current coming back from this other conductor. That's why using a clamp for locating services is often better than using a clip. Although it puts less signal, it lights up fewer other utilities. Let's go back down to where we located down close to the street. We pick this line up again. Here's my line, same place I had before. Same depth measurement as I had before. And you'll see here that, like before when the peak bar was in blue, indicating we had some distortion, now it's turned to green, which means this is a much more reliable signal. So everything's looking good. We have less current, but it's a more usable current. I'm just going to skip right ahead down to the street. So at this point, when we were here a minute ago with using direct connection, we had good signal. My peak bar is turned red now, which means we got a little bit of distortion here. Here's my high response. Here's my peak response right here. A little red bar touches the blue bar right there, right there. My peak response is here under my foot, and the null response is pushed over here a little bit. So we got a little bit of distortion here. Again, bars turning red to indicate that. Depth measurements, 1 foot 9. I have 9 milliamps of current. Let's confirm the depth. Let's see how accurate the depth is. Although we can see we've got some distortion, the depth may not be accurate. Let's see what happens. Raise it up about a foot. It went from 1 foot 9 to 2 foot 5. Not as accurate as it was a minute ago, but we have a good clean signal. Peak and null are close to each other. Good strong current. Very comfortable with this locate. Let's go back over to see if we pick the primary cable up now, the way we did a minute ago. When I walk over top of the primary trench, I have a little bit of signal here. I'll turn my gain up. Here it is. So I'm still picking my signal up here. My compass is still showing me the orientation. My peak is under my foot, and the null response is, again, way down here. So in this case, I have now about 3 milliamps of current on this line and about 9 milliamps over there. Clearly, current measurement proves that's our line, not this one. This is just some other conductor. That's a good way to think about the locating power surfaces using a clip or a clamp. Clamping gives you less current, but may often give you a more discernible signal. Well, we've done the power. Let's switch over to gas and see how that works out. We'll disconnect the signal clamp, unplug it, flip our leads back in. Now, we did most of the power at 33K, but we're going to do the gas at 8K. 8K is a better frequency for gas in most cases. Nice low frequency, signals travel a long way. They also don't jump over or under other conductors near as much. Made our direct connection to the gas trace wire. We've got 25 milliamps of output. We're in 33K, so I'll switch now to 8K. Just push the frequency button until I can see 8K right there. 8.19, we round that to 8 kilohertz. My signal output says 0 milliamps. I'll just make sure I have a good connection here. So now I've got 15 milliamps, 20 milliamps. That looks to be it. It's a good locate signal. 8 kilohertz, 20 milliamps. Let's do a locate. Grab the receiver. Walk over to where we had this signal over here a minute ago. Switch the receiver now to 8 kilohertz from 33, which is where we last used it. There it is. Move my receiver across it. Here's my signal right here. My signal strongest right here. This is my peak response. I see I'm still in omni mode, so I won't get the peak and null arrows. So I'll switch back to peak and arrows. Peak with arrows. There's peak. There's my arrows. So my peak and null are lining up nicely. The field's green already, which means it's a nice clean field. The compass is lighting up nicely, telling me I'm going in the right direction. I've got about 17 milliamps of current here. And I've got about 3 feet deep. If I raise this thing up a foot, it should say about 4 foot. And it says 3 foot 11, 3 foot 10. So we're getting a good depth measurement, lots of current. A minute ago, when we lit the power utility up, we lit up that one and this one. Let's go across and see whether they're putting any signal on the power line at this point. All my indicators are I'm not, because my peak and null are lining up perfectly here. Let's walk over here to where we had signal a minute ago. I see a small amount of signal. Have a look at this. I see just a small amount of signal popping up at the bottom of the screen, which means there is signal, but it's very weak. So if I increase my gain a little bit, here's my line. So this is the power line we located a minute ago. My peak response is right here. I'll cut my foot under it. My null response is now way over here. The reason is the signal is going out on the gas line and some of it's coming back on the power line. So in this case, we can see we've got 4 milliamps of current as opposed to 11 or 12 milliamps over there. So the opposite now is true of what it was a minute ago. This is not our target line. This is return path conductor. The other one is our target line. So we could ignore this one safely and continue locating. So I turn the gain up to find that line. As I come back over top of my target line, I'll go right off scale. I stop, turn the gain down, and begin my locate. So already I can see I have a nice clean field, and I continue following it. In fact, you don't even have to swing the receiver. If the line's going in a straight line, just walking in a straight line will allow you to continue hearing signal. Let me show you what I mean by that. I can pick the signal up here, and as I walk this way, I just stay on top of it. I can hear it. One thing you'll hear, though, is the signal's getting weaker. The signal would get weaker as you walk away from our transmitter, but there's another reason signal gets weaker, and that is the conductor's going down deeper. Let's have a quick look at that. Here's my strong signal right here, and my peak and null line up. It says I'm about 3 foot 8 inches deep. Now I'll step forward, listen to the signal get weaker. 3 foot 8 back there, and here I am now 5 foot 8 inches deep. So I've dropped down from 3 foot 8, I've dropped down 2 feet. My peak and null still line up nicely, so we still have a nice clean field. It says 5 foot 10. I'm going to raise the receiver up about a foot, and now it says 6 foot 11. So we're getting good depth measurement, but that indicates or illustrates why my signal got weaker as I walked away from my transmitter and as the conductor went deeper. This line was drilled in, so I know it drops down to about 19 feet up ahead of us. So if we just continue following this line, we'll hear it getting weaker and weaker. As the signal gets so weak we lose the signal right around here. Let's have a look at it now. Now my line, let's do our peak and null. There's the peak, there's the null, lines up nicely. Now we're 8 feet deep. If I still have lots and lots of current, of my 25 milliamps, I still have 19 milliamps to work with. As I raise the receiver up from 8 foot, it should read about 9 foot or so, and there it is, 9 foot 2. So we got a good depth measurement, good current measurement. We made signal back at the transmitter. We found signal here. We also found signal on the other line, but by comparing the two fields, peak and null and current and depth, we can confirm that this is the line we want to be on, not that one. So now we've emerged from the other side of the small forest here. The gas service is going across the street to where the gas main is. As I can locate this line, I can clearly see the conductor is right here. My peak and null line up beautifully. I got about 7.5 feet of depth. If I raise the receiver about a foot, I got about 8.5 feet. So we know we're still in the same line. I still have 22 milliamps of current. Lots of proof for the line we want to be on. So as we follow under the ditch, this line was drilled in underneath this road. As we follow it across the street, we can still see the lines quite deep beneath us here. In fact, let's have a look. Here's my strongest signal. Still 20 milliamps of current, about 6 foot 4 inches deep. Peak and null line up beautifully. I'll raise it up about a foot, and it says 7 foot 1, so we still got a good depth measurement. Let's continue on. Gas main's just the other side of the ditch here. As I get to here, I've got tons of signal. And the reason is because the lines come quite a bit shallower. Now I'm only 3 feet deep, still lots of current. Rotate it, pick up the line, find my strongest signal. And now I'm about 3 foot 10. So I've gone from 3 foot to 3 foot 10, still a good depth measurement. The service is going to join the main just ahead. It's a good illustration of what happens when you make a direct connection onto a trace wire or a gas service. When that signal we put on that line, that conductor hits the main or another piece of trace wire, the signal will split oftentimes and go in one direction or the other, or sometimes both. As the signal hits the gas main up ahead of me, some will go left, some will go right, and so we won't know until we actually see what happens as a result. Generally, the reason that more current gets pulled in one direction is because there's an easier path to ground in that direction, an easier path for current to travel on. So let's follow the signal. If we just go by sound, we pick it up. We lose our signal around here. I simply step back to where I had signal, here. And instead of sweeping this way, I start to swing the receiver in this direction. So what happens is, as I walk past here, now I hear noise on this side of me, and a little bit of noise, very weak sound on this side. So that indicates that most of my current's being pulled in that direction. Let's have a look at that. So if I stand right here on the service, here's exactly where the service is, right here, not around here somewhere. Come on and have a look. You can see the compass is already changing direction, which means it's telling me that this conductor is traveling more to the signal is traveling more to my left than it is to the right. If I rotate this, I can get it to turn blue. Sometimes it doesn't want to turn blue on you if you're right on top of the connection. But my peak response is right here. And my null response is right on top of it. So we got a good clean field, 16 milliamps of current, 2 foot 9 inches deep, and we think most of it's going to travel in that direction. Remember 16 milliamps. We pick the receiver up, we move in this direction, follow on the main right here, and we end up picking up a good strong signal right here. Now this is an interesting illustration of what happens when you locate a conductor that's directly underneath a metal culvert. So the gas service itself was installed, the culvert came in, and they put it right on top of it. My peak response will tell me this line is right here, or it says my field is strongest right here. My null is in agreement. It says, yeah, I agree with you. It says it's 3 foot 2 inches down. Let's raise it a foot and see what it says. And now it says, it still says 4 foot 2, so it's a remarkably accurate depth measurement considering the line actually runs right under that metal culvert. It's not at all unusual to see the field so badly distorted as it rises up through a metal culvert that you'll get poor depth measurements in that vicinity. We have 10 milliamps of current here. I think we had 13 over there, so the bulk of our current's traveling in this direction. And at 8 kilohertz, we can likely follow this line way down the street with lots and lots of signal. Let's go back to the other side and see what happens to the signal in that direction. Because this gas main does travel in 2 directions. We picked it up traveling this way. The easiest way to find this one, the path of this one, is not to do it from here, but to step forward 5 or 10 feet in this direction and then sweep the receiver. And when I do that, I can see my signal is strongest right here. There's my peak response. And my null response is way over here. The reason the peak and null don't agree with each other here is because the large magnetic field in the conductor traveling across the street, and most of it going in that direction, that large field is pushing on this weaker field, big magnet, small magnet, and when the 2 magnets come in close to each other, the weaker field gets pushed a long way away. So in this case, it says I have about 2 milliamps or 3 milliamps of current. It says it's 2 foot 8 inches deep. Because the receiver's already told me that the field is distorted, I don't expect to get good depth measurement here. My peak's here, my null's way out there somewhere. If I raise the receiver up a foot, now it goes from 2 foot 8, 2 foot 7, I should say, to 2 foot 9. Poor depth measurement here, great depth measurement there. The only place we're going to start to get good depth measurements here is when this field cleans up enough to give it to us. So let's follow this line. In fact, the most important thing in a locate is where is the conductor, not everything else, depth and current. But if I turn my receiver, my sensitivity up a little bit, and I need to because the field got weaker coming in this direction and that direction, I can continue to locate this line. So I can very confidently say that gas main is right here. Now let's have a look at our field here now. My peak response says the conductor is right here. There's my strongest signal. I'll put my foot. My null response says move that way a little bit. And when I do, the null response is now here. So we're getting a null response over here somewhere, still quite a bit of distortion, peak here, null over there. So that means the field still isn't clean enough to give me an accurate depth or current measurement. Let's keep going. Continue to follow this line. I'm still following the gas main very nicely. Here's my strong signal right here now. My peak response is here. My null response it's a lot closer, but it still isn't right on top of it. So there's my null response there, and my peak response is here. So they're much closer. Here we're going to start to get better depth measurement and better current measurement. I have 5 milliamps of current here, 4 foot 7. Let's raise it up about a foot. And now I have 5 foot 8. So we're getting good depth measurement here, where we were not getting good depth measurement there. And my current measurement is it's good, but the other one is way gooder. So clearly we can see that this is the same line we are on because our current's nice and high. Well, let's summarize. We hooked our transmitter on up there at the connection, the service connection. The signal came across the street and split in 2 directions here on the gas main. Most of our current got pulled in this direction, some of it got pushed in this direction. That's an important distinction with line locating. Current gets pulled way easier than it gets pushed. Because there's an easier path to ground in this direction, more of the current got pulled this way. In fact, of the 16 milliamps we had coming to this point, 10 of them went that way, and as we saw a minute ago, 5 of them went that way. So 5 and 10 add to about the 15 or 16 we had. Sometimes the signal splits equally. Sometimes if you're close to the end of a service, almost no signal goes in that direction. It all goes in that direction. And when that happens, you'd have to, if you needed to locate this main here, you'd have to hook your transmitter up somewhere further up in that direction and let the current again get pulled down in the direction towards the easiest path to ground. One more thing. If we hooked up our transmitter to the service, the next service down the street here, the current would travel out to the main and go smoking right down the street to try and get the ground on the larger piece of metal out there. Very little, if any, of it would travel up this service because the trace wire at the far end of the service is hanging up in midair. We could possibly get more current to travel up that if we used a higher frequency, say 83 kilohertz. We might be able to hook up a transmitter there and locate the main and this service because a higher frequency doesn't need a path to ground as much as lower frequencies do. But we tend to locate gas using 8 kilohertz. So one more thing I want to say. The good locators make signals if that's what they're doing with a transmitter, and then they find them and mark them. What I've learned over the years is that great locators, the ones that are really good at doing this, do one step further. They make the signal the same way anyone else was. They find the signal, or in this case, the signals, one signal here, another signal here, another signal here, and then they stop and look at those signals, those fields, if you will. They compare the fields they're looking at with what they expect to see. So we had 16 milliamps coming across the street. When I stopped and looked at it, I could see my depth was good, my current measurement was good. As I went around the corner, I could see that the bulk of my current got pulled in this direction. But because I started out with 16 and only had 10, I knew that there was another 5 somewhere else. So when we swung back over the main and walked out there, we walked far enough down this main until the field was clean enough to give us good depth current measurement, which in this case was close to 30 or 35 feet. We only had to go 10 or 15 feet in that direction before the field's cleaned up to give us good depth and current. We had to go quite a bit further to find it there. So let's talk a little bit about the receiver itself. Not unlike the transmitter, that's the on-off button. This is gainer sensitivity. I'm going to turn my volume down just here a little bit so we can get it a bit quieter. I'll scroll down to the speaker volume and I'll turn my higher, and off. There's my speaker turned off just while we're having this chat. So I want to get out. When I'm done, I hit the I button to get back out again. And now we're doing locate. So here we are. We're in classic peak null mode, peak with arrows. I'm going to switch over now to the vector mode. Do that by pushing and holding the M button. And here I am in vector mode. So what that shows us is us up on the surface, the conductor beneath us. As we move the receiver back and forth, we can see the conductor changing position beneath us. Finally, we're put right on top of it right here. We're standing right on top. Continuous depth, continuous current measurement, same as before in peak and null. I also have a panel over here that shows me the orientation or direction of the conductor beneath me, as opposed to a compass. So if I rotate the receiver like so, you can see that line changes. I come back to here, it tells me where it is. Here's a great illustration of how the offset of the vector mode can really help you get a good locate. If I stand in the bottom of this ditch and locate the gas main, from here I can see it's about 3 feet deep. If I raise it up to about here, it tells me it's about 5'1". But if I wanted to locate this line from over here, I can stand right here. I can adjust my gainer sensitivity, get my signal. It tells me the line is 9'1" in that direction. That's about 5'5" deep. So if this ditch was full of freezing water or snow and I couldn't get out onto it to actually do the locate, I could simply use vector mode, locate the line from here, know how far away it is and how deep it is from this point anyway, out in that area. Let's push the button one more time. We'll go into what's called plan view. Plan view is the simplest locate mode. It's a great mode for people who are just beginning in locating. All it shows you is the conductor itself, nothing else. But because the colors change, it'll give you some idea what the field looks like down there in terms of distortion. That's the plan view indicator right there, and it's also omnidirectional. So no matter what direction I come at this from, it shows me where this thing is. Even if I cross it this way, I can still see the conductor beneath me. In fact, if I go far enough away where it's right off scale, an arrow pops up on screen and moves me back towards where the conductor actually is, and that allows me then to pick it up, line up myself on top of it. This will allow me to walk and locate very quickly. I can walk in a real hurry, just make sure every once in a while that I can see that conductor beneath me. If I had my volume turned up, I'd continue to hear the sound as we did a minute ago. In fact, let's turn the volume up a little bit just so we can hear that. We go back to speaker volume, give us a little bit of volume. Right there. So now we'll be able to hear the signal. In fact, in this mode, plan view, you hear two different signals on either side of the conductor. You hear this tone on one side and this tone on the other side, a slightly higher pitch, which allows you then to locate just walking and listening for where the change of pitch takes place, to a rapid locate to get you down to where you want to get to. Let's continue on. We're back to classic peak and null here now, just by pushing and holding. In this mode, when I'm in peak and null, if I hit the button, a short push like that, then what'll happen is I'll be in omnidirection mode, which means I can locate this line this way, a traditional locate, but I can also locate the same line walking this way. From any direction, the coils will pick up that signal, allow me to locate it, adjust my gain down, and get my locate done. So omnidirection means no matter what direction you cross the field in, you'll pick it up. I'm just going to turn my volume down here a little bit. Push and hold, up and down, right there. That's the way I want it, just minimal volume. So now I can quickly locate in peak and null, either omnidirection or classic peak and null. I can use vector mode or I can use plan mode, get my locate done in a hurry. The way we achieve the additional information is by using more coils. This is one of the biggest changes that have taken place in line locating in the last 25 or 30 years. We now use a multiple coil array, multiple coils in different orientations, peak and null, with omnidirectional capability. So from any position, we can pick up that field beneath us and actually get the locate done. It's part of why Vivax Metrotech is becoming the most widely used locator in the world. You know, one of the most important elements of a line locate is gathering enough information to put paint down with a high degree of confidence. That's what Vivax Metrotech is always focused on, providing the user enough information to do locates with confidence. What that means is good, strong signal to begin with, and then lots of different ways of looking at that field to satisfy themselves that this is the line I really want to put my paint on. It's more than just finding a signal. It's actually finding that signal and then getting enough information through the receiver to decide whether this is the line I really want to locate. That's what we focus on.